Hello, this is Ms. Clausing. Okay, so here's the Unit 5 review. I'm not going to do all of these, but I will do some of them. Okay, so this will help you kind of work through it if you get stuck on any of the sections. So this top section here, the instructions say simplify each radical expression. So let's just start with number 1. Some of these are a little hard to read on this screen, but you have the handout, so you should be able to see them. Okay, so number 1, all I'm doing when I'm simplifying, and remember we kind of rewrote this in class as simplify is kind of in non-math terms, is you're take out as much as possible or anything you can possible from under the radical. From under the radical, which is really our radicand, right? But we're using non-math terms for this, just so from under radical sign, okay? Okay, so I'm taking out as much as possible. That's what my simplifying is doing, okay? So let's just start with our 50. We have to think about it. We're taking a square root here. So is 50 a perfect square? It's not, but I want to think, are there any factors of 50 that are perfect squares? So sure enough, 25 and 2. 25 is a perfect square. 25 times 2 gives me my 50. So I can rewrite this. Square root of 25 means 5 comes out from under the radical. I'm going to leave a little space, draw my new radical sign, and this 2 is stuck under the radical. Okay? So then I go to a to the 8th. Remember to figure out for our variables, our variables, to figure out how many a's we can take out, we take the exponent of 8, and we divide it by our index, which is a 2. 2 goes into 8 4 times, so 4 a's will come out front and join that 5. Okay, so then the last one, b to the 5th, again I take my exponent of 5, divide it by my index of 2, and 2 goes into 5 2 times, completely, and then I have a remainder of 1, right? Because 2 times 2 gives me 4, 5 minus 4 gives me my remainder of 1. Okay, so 2 of my b's come out front, 2 b's come out front, and my remainder b to the first, sorry, not a 2. Remainder b to the first stays under the radical. Okay? So that should be a b to the first, which again, you don't have to write that 1 there, but you can. Okay, and then c to the first. C doesn't have a partner. Right now my exponent on this c is a 1, so it needs a partner because my index is a 2. So I need at least 2 c's to be able to take any c's out from under the radical. I can't take any c's out, so my c will just stay under the radical with my 2 and my b. Okay, so let's just clean this up a little bit, rewrite it so it's a little easier to see. So I have on the outside here, I have 5a to the 4th b squared, square root of 2b to the first c. Okay, and this is my answer. Alright, so let's see, next one. Let's talk about I'll skip number 2. All you're doing, I'll get you started on number 2. How about that? All right, number 2, remember when I have an exponent out here, the exponent, you can't really see it up here, but you can on your sheet, is actually 1/3. Okay, it's an exponent of 1/3. Also, it doesn't look like an exponent, but it's an exponent of 1/3 on the outside of that parenthesis. All right, to get this, rid of this exponent on the outside, I just distribute it to every single exponent on the inside. Remember the exponent on my 64, it does have 1, and the exponent is a 1. So this is a 1/3, and the exponent on that 64 is a 1. When I don't see the exponent, I know it's a 1. So I need to distribute this 1/3 to every every exponent inside the parentheses. I distribute it by multiplying, so I will multiply here. So I will end up with 64 to the 1 times 1/3, which is 64 to the 1/3. Put that in my calculator. Then 11 times 1/3. That would give me 11/3. Okay? So get you started on that one. All right, number 3. Here we're multiplying 2 radicals. Remember the rules. To multiply 2 radicals, look back at your notes. To multiply 2 radicals, I need to make sure my indexes are the same. Okay, so when we're multiplying radicals, let's just quickly write these steps down. multiplying or dividing. Step 1, I need the same index. Step 2, if I have the same index, remember I said you multiply the outsides or divide, whatever it's telling you to do. Divide the outsides. Okay, and then step 3, I multiply or divide my radicand, which is really, remember, it's kind of like our insides. Hopefully you can read this over these date and stuff. Radicand, which is really my insides, or what's under the radical. Okay, and then once I do that, step 4 is just to simplify. Alright, so let's do that. We'll do one of these. Let's do 3. 5 will follow the same steps. You just gotta divide instead of multiply. So my indexes are the same. My indexes are 2, which is a little number in the pocket. Okay. So I'm going to multiply. I don't have anything on the outside here. That 2 is an index. It's not like a coefficient or a number outside. So I don't need to do anything on the outside. So I can actually skip step 2. I've checked step 1. They have the same index. Step 2, there's nothing out there. So it doesn't really apply. So I don't need to do step 2. Step 3, multiply my radicands. All right, remember you're multiplying the like terms. So I have a 10 and a 2. 10 times 2 gives me 20. Then I have an a cubed and an a to the 6. Now, remember your exponent rules. When you have when you're multiplying variables, you add their exponents. So 3 plus 6 equals 9. So that gives me, let me move this 20 down so I have more space. So 3 plus 6 equals 9, which gives me an a to the 9th. I'll put this 20 back from our 10 times our 2. Okay, and then lastly we have a b. And remember, I don't see the exponent on this b, but I know it's a 1. And I know the exponent on this b is also a 1. So I have 1 plus 1 gives me 2, so I have a b squared. Okay? Now, these are all still under my radical sign. Okay? They're all still under the radical sign. We've just now completed step 3. Okay? Now I have to go to step 4. You're also used to seeing numbers out front of our radical, because generally we do have to multiply numbers that are outside the radical. You just don't have to in this example because there is nothing out there. All right, so under the radical, now I just need to simplify. Remember, simplifying, like I said over here, you take out as much as possible from under your radical. Okay, so let's start with this 20. We think about, is 20 perfect square? It's not. But I need to think, are there any factors of 20 that are perfect squares? And there are. 20 can be, factors of 20 are 4 and 5. 4 times 5 gives me 20. And so the square root of 4 is a perfect square, so that will be a 2. And this 5 will leave a little space. This 5 is stuck under the radical. Okay, so I go to a to the 9th. Remember, to see how many a's I can take out, I take the exponent of 9, divide it by my index of 2. Remember, my index is right here. If I don't see it, it's a 2. And 2 goes into 9 4 times with the remainder of 1. So 4 a's will come out front, and 1 a stays under the radical. All right, let's take out our b. So I have 2 b's, and I want to take out 2 of them. So I could just think about it, and I could go, well, I need them in pairs, and I have 1 pair of b's, so 1 b comes out front. Or you can follow the same steps we've always been following. Take the exponent of 2, divide it by my index of 2. That gives me 1 b that comes out front. Okay? And that's the answer for that one. All right. Okay, so 5. Same steps as 3, except now you're going to just divide instead of multiply. And number 4 is basically the same steps as number 1, except make sure you're careful. Number 4 has an index of 3. It's not a square root. Okay? Okay, so let's go down to this next question down here, which is equivalent. So if you notice here, really it's saying which is equivalent, but you got to think about it a little bit in that in our problem, or in our question, it gives us a radical form, and all of our answer choices, A, B, C, and D, are all in exponent form. So really what it's wanting me to do is just take my radical form and translate it, or whatever, turn it into exponent form. All right, so let's do that. So when I have a sixth root, remember that's the same thing as writing anything under the radical, the radicand, write the radicand, I'm just going to rewrite it, and I'm going to raise it to the 1/6 power. Okay? Alright, so once I get to that step, still doesn't match any of my answer choices, but that makes sense because I need to distribute, like we did in the earlier, I need to distribute this 1/6 to everything inside my parentheses, or every exponent inside my parentheses. So we have 2 times 1/6. Again, you can just put this in your calculator and turn it back into a fraction again. But this would give me 2/6. So that means I have A to the 2/6. Okay? And then I have 1/6 times this 3 right here. So I have 1/6 times 3, which equals 3/6. And if I reduce that fraction, again, you can use your calculator to do this. We need to reduce our 2/6 as well, actually. When I reduce 2/6, it actually gives me 1/3, because you can't leave it with a non-reduced fraction, so we really have A to the 1/3. Everyone follow that? I just reduced my 2/6 to 1/3 from here to here, and then the 1/3 is what actually goes up with my exponent. Okay, so then 3/6, I need to reduce that, and that reduces to 1/2. So then I have B to the 1/2. And then I need to find which of my answer choices match, and that would be a D. Okay? Alright, so that's how you do that one. Number 7, you just plug it in your calculator. And you should get, for number 7, it should equal 125. Okay, just so you can check yourself. Just put it in your calculator. 8. All you're doing is simplifying here. These are just using those same multiplying and dividing rules that we listed at the top of this page in green up here. Multiplying and dividing. So I'm not going to go over all those. Remember the main thing, you just got to check, make sure your index is the same. Then you multiply or divide the outsides. Multiply or divide the insides. So for B, you would, divide 2 divided by 3, which is going to stay as a fraction. So and for now, I would just write it down as, all right, we'll go through it. So 2 divided by 3, and then I multiply or divide by insides, and I do my like terms. So I have 72 divided by 8, which gives me a 9. Remember, this is inside my radical, so it's still going to be inside, so I have a 9. And then I subtract my exponents. Let's just keep this as a fraction for now. We'll figure out if we can change it later. So I have 2 divided by 3, and I don't change those because they don't simplify any further. Okay, they would only simplify to a decimal. They'd only change to a decimal, and then it'd go right back to 2/3. So that'll stay the same. But 72 divided by 8 would give me a 9. And then x to the 3rd divided by x to the 9th. Remember, when I'm dividing variables, I subtract their exponents. So I have 3 minus 9, which equals a -6. So I have x to the -6. Since it's a negative, that means I'm going to move it to the denominator. And I have square root of x to the 6th in the denominator. Okay, and then I need to see if I can simplify either of my radicals further. Because remember, step 4 up here, last step right here, is simplify. Okay, so let's see if we can simplify. Let's start with our numerator. So square root of 9, yep, sure enough, square root of 9 becomes 3. So I have 2 times 3 in my numerator. And then down here, how many x's can come out from under the radical? So I have an exponent of 6. I divide it by my index of 2. And that tells me 3 x's can come out. Nothing stays under. I already have a 3 out there. So joining my 3 that was already outside, this 3 right here, will be an x to the 3rd. Okay, now let's just clean this up a little bit. The numerator, 2 times 3 is 6 over 3x to the third. Again, cleaning up a little bit further. 6 divided by 3 is really 2. So I have 2 over x to the third. And this is the simplest form of b. So we're doing this one right here, right? Okay, so that's that one. Be really careful on C, because C is actually multiplying, right? It looks like it might be subtracting, but it's multiplying by a -4 right here. It's multiplying by a negative number, okay? So you're going to use those same rules we wrote down up here in green to multiply two radicals, okay? All right, so let's go down here, skip around a little bit. Let's go to, oh yeah, let's do some adding and subtracting. Okay, I'm going to erase a little bit of this, but you can always rewind this if you need to. Okay, so when I'm adding and subtracting radicals, let's do A. I'm adding and subtracting radicals. Let's list out our steps really fast. So add or subtract radicals. Okay. Step 1, we need to make sure we have the same index. Okay, step 2, we need to make sure we have the same radicand. Okay. Step 3, sorry, let's fix this real quick. If we do not have the same radicand, so if not, then we need to simplify to make them the same, to make radicands the same. If we can. We may not always be able to, but we can try. Okay, so this is like a side step in step 2. All right, so if we get them to match, if we can, then we go on to step 3. If we can't, then we can't combine them and we stop and we move on with we go to the next question. But if we can make them match, then on step 3, we are going to add or subtract, depending on what we're doing, or what the problem tells us to do. Add or subtract are the outsides. Okay. And then step 4, we just got to see if we can simplify any of the radicals further. Because sometimes we may not have simplified them all the way and they still matched, and we have to just check. So I'll put a question mark. You may or may not have to simplify it further, but you got to see if you can simplify the radical further. All right, so we got our steps there. All right, so let's do A. So remember what I said, you always kind of start with the radical that you can't simplify further. So right here I have a square root of 3. I can't change that. 3 is not a perfect square. None of its factors are perfect squares. So I'm going to try and make my other two radicals, this one and this one, try and make them match my square root of 3 right here. All right, so let's start with this 12. Okay, if I put 3 as one of the factors, 12 divided by 3 gives me a 4. This is my other factor, and that's perfect because I'm doing a square root, and 4 is a perfect square. So when I take the square root of 4, I have a negative out front, so my negative will follow it. And then this square root of 4 gives me a 2 out front, and then underneath the radical is my 3. Okay, so we got that one taken care of. Let's just copy down this middle term that we can't change. All right, so now let's try and make this 27 match. Again, it needs to have a 3 as one of the factors. 27 divided by 3 is going to give me, actually I'm going to write this over here because it'll match up a little better. All right, 27 divided by 3 gives me a 9, and that's perfect because 9 is a perfect square. So square root of 9 is 3, comes out from under the radical, and then stuck under it is this 3 right here, the other factor. All right, so now all my indexes match, all of my radicands match. So I'm going to go down here. I took care of this step, I took care of this step, I took care of that little asterisk right there. And I'm going to come down here to number 3, add, subtract my outsides. Remember when we say outsides, what I'm really talking about are these numbers outside my radicals. So I have 3 plus a 3. So 3 plus 3 gives me 6. And then minus 2 gives me a negative 4. And then that's all sorts of funky. So this gives me a negative 4. And then my radicand, or my radical just follows it, square root of 3. So this is my answer. All right, so that's adding and subtracting. Alright, so you can go on to B and do B. Now you gotta be a little more careful with B because remember, we only add or subtract the outsides when they're like terms. If I had a variable here, I cannot combine 3x with a 6. Okay, I would end up with a 3. See, these radicands already matched here, which they don't, so you're gonna have to do a little work to get them to match. But you're still gonna have an x on the outside. So you're gonna end up with a 3x. Well, without doing it, you can't do it, but I'm not gonna go over it right now. Don't think it's on your test, but so we'll go over that one, but that one it's a little trickier, but this one is more like, the one we did is more likely what you're going to see. Okay, so let's go on to multiply and then simplify. Okay, so down here, we're doing, I was going to get you started. I think you all probably feel pretty good with this, seems like. But remember, we have basically 2 binomials here. 1 term, 2 terms. Then we have another term, 2 terms. So 2 binomials, when we multiply binomials, we use FOIL. Okay, the only little trick you have to remember is, like here in B, I have 2 binomials that look exactly the same, except that one binomial has a plus sign, and one binomial has a minus sign. Those, remember, are called conjugates. And when we have conjugates, when you still would multiply them out to combine the 2 binomials, right? This binomial would multiply by this binomial, but we don't have to do all of FOIL. Remember, we don't have to do the O or the I because they end up canceling out. When you have conjugates, you only have to do first and you only have to do last. Okay, so I would do 5 times 5 gives me 25. And last, I have -3 times a +3 gives me a -9. And then square root of 2 times square root of 2. Remember, when I have square root times a square root, they're exactly the same. Out pops a radicand, so out pops a 2. And so let's just clean this up. 9 times 2 is 18, so I have 25 minus 18, which equals 7. That would be my answer there. That's when you have conjugates only, then you don't have to do all of FOIL. You can just do the first and the last step of FOIL. But over here in A, you do have to do all of FOIL. So you do first times first. First times first would give us a 2 on the outside, and remember what I said, we have 2 radicals that are exactly the same, out pops the radicand, so we end up with a 2 and an x. And then we have outer, so we have 2 root x times a -7, which gives me a -14 root x. And then we have inner, which gives me a +3 root x. And we have last, which gives me a 7 times 3 gives me a -21. And let's just clean this up a little bit. In the middle here, we have 2 like terms. We have a -14x and a 3x. So -14 plus 3 gives me a -11x. Sorry, 11 root x. And we have our -21 at the back, and we still have this 2x at the front. Okay, so that would be the answer for A. Okay, so let's go down to this next one. Simplify. Alright, so when we're simplifying, remember we need to distribute this exponent on the outside. This 4 needs to distribute to every exponent on the inside. Where I don't see an exponent on a constant or a coefficient, remember it's a 1, okay? So now I'm going to distribute this 4 to every single exponent on the inside. Okay, and then I distribute it again to the denominator, 1/3, and let's see how I can do this up. Okay, and up here to this 4 here. Alright, so 4 times 1, I'm going to start up here in the top. 3 gives me a 3 to the 4th power. 4 times 2/5 gives me an x, where we have 2/5 times 4 gives me an x to the 8/5 power. Yeah, we're going to need a lot more space here. Okay, so that first one gave me a 3 to the 4th power, right? That was 1 times 4. All right, and then I got an x to the 8/5 power, which was because we did this 4 times the 2/5. Okay. And then I did y, which was a 1, so I have 1 times 4, which gives me a y to the 4th power. And then again, my x has in the numerator has a 1 exponent on it, so it's another 1 times 4, which gives me an x to the 4th power as well. Then I go to my denominator, do the same thing. I have 4 times the 4 on the x in the denominator, which gives me an x to the 16th, right? I did 4 times 4, gave me my 16. And then I have this 4 times the 1/3 on the y, times the 1/3 on the y, which gave me a y to the 4/3. Alright, so now I just need to simplify whatever I can simplify here. So it's a lot different when we're simplifying without radicals, because before I said when you're simplifying, you're really just trying, when we're talking about radicals, when we get to that last step of adding or subtracting or multiplying or dividing radicals, we're trying to take as much out from under the radical sign as we can. But when we're talking about here, we're going to try and basically combine as many of these pieces as we can. And the pieces we're going to combine, okay, we're right here, right? We need to combine as many pieces as we can. All right. So I have an x in the numerator and an x in the denominator. Okay, so I'm going to take their exponents. I have an x divided by an x. When I'm dividing two variables that are the same, I subtract their exponents. So that gives me an 8/5 minus 16. Okay, and I can just pull up my calculator. Here, I'll pull up this calculator. Okay, let's see. And I just put in, I have 8 divided by 5. It's very important you use your parentheses. Minus 16. It'll give me a decimal, and then I just math frac it. So math frac is number 1. Negative 72/5. We'll just leave that like that. So we have, this gives me a negative 72/5. So I have a negative, which means it's going to stay in the denominator. So in the numerator, I have this 3. I don't have another constant in the denominator, so my 3 will go, keep our numbers the same, or our colors. 3 just stays there. Alright, so then this x that we're taking care of, remember the negative sign right here tells me it's going in the denominator, so I have x to the 72/5. Remember, when I put in the denominator, it gets rid of the negative. Okay. So I'm thinking, actually, nope, sorry. Okay, so then I go to the next piece. I have y to the 4th divided by y to the 4/3. So I do 4 minus 4/3. Just go to my calculator. 4 minus 4 divided by 3 equals 2.66. Math frac it. And I get 8/3. Okay? So this equals 8/3. Which is positive, so the y is going to come up here and join the 3, y to the 8/3. All right, and then this x to the 4th, is that always an x? Oh, this is a really quirky problem. All right, so I still have x to the 4th in the numerator here, so let's just write that down. We will need to combine that, though. So I have x to the 4th here in the numerator. Alright, so we get down here. But we're not quite done. Let's see if we can combine this x to the 4th and this x to the 72/5. So Everything else I'm going to write down my 3, my y to the 8/3. They're already like all combined. There's no other y's and there's no other constants in this problem. So I'm going to write down 3 and my y to the 8/3. Those aren't going to change. But this x to the 4th and the 72/5, I need to combine those. So I'm dividing two variables, so I need to subtract their exponents. So I have a 4. I'll do it right here. I have a 4 minus 72/5. So let's go over here. We do 4 minus 72 divided by 5. Gives me 10.4. Math, frac. Negative 52/5. It's still going to be in the denominator, but it will give me the denominator an x. What was it, 52/5? Yeah, 52/5. 10/52. Okay, and that's my answer right there. All right. Number 13. Remember, this was on your quiz. All you're doing is you're taking, let me erase this again. You can pause this if you need to finish that last problem, number 11. But okay, so number 13. All I'm doing is I'm taking this radical and turning it into an exponent to get started. So I have 729, a to the 14th, b to the 3rd, c to the 12th. Just rewrite my radicand. And since it's an index of 6, remember that's the same thing as writing everything in the whole radicand to the 1/6 power. All right, and then I just distribute that 1/6 into everything in the parentheses. So I have 729. Remember, it's really to the first power, so 729, 1/6 times 1 gives me 729 to the 1/6 power. 1/6 times 14 gives me a to the 14/6 power. We'll reduce our fractions in a second. And then we have b, 3 times 1/6 gives me b to the 3/6 power. And then c, we have c to the 12th, so 12 times 1/6 gives me c to the 12/6 power. Okay, so now I just need to simplify the fractions I can, see if the 729 can be simplified at all. So let's start there. So I'm going to put 729 to the 1/6 in my calculator. 29 to the 1 divided by 6 gives me 3. Okay, so this 729 becomes a 3. Alright, then 14 divided by 6, that simplifies. Again, I can just type that in my calculator in the math bracket, get a decimal in math bracket to get the simplest fraction, or if you know how to simplify your fractions, you get a to the 7/3, and then we get b to the 1/2, and we get c squared. Okay, and that's the answer there. Alright, and remember, if this 6 of 13 up here, if this 6, my index was like a 3, I remember I would have raised this to a different power. It would have been to the 1/3 power. Okay, and then I would distribute a 1/3 to everything inside the, all the exponents inside the parentheses. Okay, so let's go on to the other page. Alright, so solving equations with radicals. We did this towards the end of the unit. Let's just do a couple of these. Let's see, let's do number 14. Sure, okay, let's do 14. All right, remember, it's kind of the same steps as when we're talking about absolute value. You want to get it clean, get radical clean. And then you can figure out how to get rid of the radical. So get radical clean, and then get rid of radical. Very non-math terms, but okay. All right, so now number 14 right here. All right, first we need to get rid of this 4. So I'm going to minus 4 to move it over. 4's cancel on the left, leave me as 2. Square root of x plus 5 equals a negative 4. Then we divide by 2. Again, I got to get everything outside of my radical away from it. That leaves me the square root of x plus 5 equals a negative 2. Negative 4 divided by 2. Alright, so then I need to get rid of this radical. My index is a 2. The inverse of, what's going to allow me to get rid of this radical is by squaring it. Okay, what I do to one side, I have to do to both sides. So my radical and my square will cancel on the left and leave me with a freed x plus 5, which is perfect. That's what I want. And then negative 2 squared is a 4. Be very careful if you type this into your calculator that you use parentheses. Otherwise, you will get the wrong answer. Okay? Negative 2 squared is positive 4. Okay. Now I just need x by itself. So I'm going to minus 5 from both sides. And that gives me x equals a negative 1. That's my answer. Okay? Alright, so that's solving. So like on 13, remember when I'm solving, I have 2 radicals on both sides. Notice on 14, I only had a radical on the left side of the equation. But here I have a radical on both sides. So to get me started, I'm just going to get rid of the radical right away. Okay, so I'm going to immediately, it's a cube root, so to get rid of the radical, I'm going to cube both sides. You just got to be careful and make sure you cube this 2 as well. So 2 cubed is 8. And then the radical here cubed cancels with that cube and leaves me with a negative x plus 3. So it's 8 times a negative x plus 3. On the left side, the radical and the cube cancel and leave me with a 2x minus 6. Alright, so now I need to get my x's all together and get my constants all on the other side. But to be able to get this x free that's inside parentheses, I need to distribute this 8 first. So 8 times a negative x gives me a negative 8x. 8 times a 3 gives me a positive 24. And I have 2x minus 6. Alright, so now I need to get all my x's together. So let's move this 8x over to the left. Line it up under its like term. That gives me a 10x minus 6 equals 24. Right, because those cancel on the right. Alright, then I need to add this 6 over. So they cancel on the left and leaves me with a 10x equals 30. And then I divide both sides by 10. And that leaves me with an x equals 3. Okay? So that's the answer for that one. Again, over here on 15, it looks more complicated. I'll get you started. I'm not going to do the whole thing. But I need to get rid of this 3. To get rid of the 3, I'm going to multiply both sides by 3. And that cancels out that 3 and leaves me the square root of 7x plus 9 equals 6. And then I need to move this 9 over, so I'm going to minus 9 from both sides. That leaves me with the square root of 7x equals a negative 3. And then I, do what we're used to doing. We need to get rid of the radical. It's a square root, so I'm going to square both sides. Be very careful you use your parentheses correctly. I'll just solve this out. That cancels with the radical. Leaves me with the 7x equals a negative 3 squared is a positive 9. Again, make sure you use your parentheses if you're putting it in your calculator. And then I'm going to divide both sides by 7. That x leaves me with x equals 9/7. So that's the answer for 15. Okay? Alright, so let's go down here and talk about some inverse of functions. Here is some of the stuff. Here again, if you need to see that stuff I'm erasing, you can just pause the video or rewind it. Woo, this is a long video. Okay, so let's go down here. Let's just do one of them. I'll do the slightly more complicated one, or I think so. So we'll just do B right here. Remember, wherever you see f of x, think of it as y. And remember with inverses, all you're doing, steps for inverses, you're switching x and y. And then you're solving for y. Okay? So I'm going to switch my x and my y. So that gives me x equals y minus 3 squared plus 1. And then I solve back for y. So I'm going to minus 1 from both sides. That gives me x minus 1 equals y minus 3 squared. Okay, I need to get rid of this square, so I'm going to do the opposite of that, which is taking the square root of both sides. So that gives me the square root and the square cancel on the right, leaves me with y minus 3 equals square root of x minus 1. Remember, I want to get y by itself, so I'm going to add 3. We'll bring this up here. So that gives me square root of x minus 1 plus 3, and be very careful. Notice where I stopped my radical sign. The 3 is not under the radical. Okay, and then on the right side, my 3's canceled. I'm left with just a y, so this equals y. So, this is my inverse equation. Remember, we can check inverses by checking the symmetry over the y equals x. You can go back to look at your day 6 part 2 notes for inverse functions if you have more questions on that. Okay, let's just talk about these quickly because I think we're pretty good on transformations. Graph, put these in your calculator. Put all of this in your calculator. All you're going to do is put, put this into y1, put this into y1, whatever. You do these all separately. They don't go together. But, and look at the graph it, find your domain and range. Transformations. Our transformations we talked about all year long. Number hanging out with my x is an x-axis shift of, and x says the opposite of what it says in the function, so it's actually a -2 shift. A number at the end is a y-axis shift. It does exactly what it says it's going to do, so that's a -5. All right, here when I have a negative out front, it's a reflection over my x-axis. Okay, and then we have an x-axis shift. Let's see, I'm going to erase some of this so it's not so. Okay, so this is an x-axis shift of -1, and this 4 is a y-axis shift of +4. Okay, and then I come down here, last one. Again, I have a number hanging out with my x, so it's an x-axis shift. Does the opposite of what it says, so it's going to be a +4. And I have a y-axis shift for this number out at the end, which is a, does exactly what it said, it's a +5. Okay? Domain and range you get from reading the graph. But remember, wherever you have a cube root, a cube function, or a cube root function, domain and range are all real numbers. Okay, so those are pretty quick. You don't even really need to look at the graph, right? Oh, sorry, I'm sure those on the wrong spot. Let's go down here where our cube root graph is, which is, so this is all real numbers. Again, negative infinity to infinity says the same thing. I'm not going to write that on all of them, but either notation is perfectly fine. You could have this notation or this notation. Doesn't matter. Okay? So that will get you mostly there. The domain and range here, I'm not going to pull up the graph because you just put it in your calculator. But my domain is going to be, remember I can use my transformations. It will be -1 to infinity, inclusive on -1. And it will be, let's see, negative infinity, it's a reflection, up to my y-axis shift of 4. And inclusive. Okay, so that's what you get when you look at the graph. Alright, so, I think we made it. Alright, have a great evening. Good luck on your test. Make sure you finish all of this review for your homework. And then also have a good weekend if I don't see you on Friday, if you're in my classes on Friday.